So to help us with what we're doing today, I just want to look at number 1 right now. If you're at home, the answer for number 2 is 25. You guys got it. This first one here says, Rebecca pays her rent each month. Write an expression to represent how much rent she pays for an entire year. And this goes back to what we had been doing, not yesterday, but Monday, in that intro to variables lesson. Francis, I'm going to start off with you. You wrote down
R times X.
R times, how did you write it? Just RX? Why can we write R times X like this?
Because you don't have to write an X when you're doing times. You don't have to do it twice.
Yeah. You don't need like the multiplication X or parentheses or a dot. You can just put 2 things next to each other and it means multiplication. So you've got R and X. You've got 2 variables. Tell me what those 2 variables represent.
R is for Rebecca, X is for rent.
So when you say R is for Rebecca, are we multiplying the human being?
No.
So give me more details.
So R is for rent.
Okay, so R is for rent.
Yeah.
And then what's X?
Each month that she pays.
Times.
So the rent times,
Each month.
you say each month.
A year.
So then I'm going to switch over to you. So you had something very similar, except you didn't have 2 variables. You just said,
12 months.
yeah. So you had,
Times 12.
I think you wrote it like this.
Yeah.
R times 12. Where's that 12 coming from?
Because an entire year. Because it's 12 months in a year.
Yeah. So yours, this is good if we just wanted an expression for how much total money she pays. But because I gave us an entire year, it means it's not an unknown. We know it's going to be 12. So we've got R times 12. This is perfect. You're saying the rent times the 12 months. The most common way you're going to see it is more similar to what you've got, Francis, where you've got the numbers next to each other. One of the things we didn't talk about last week is when you're putting them next to each other without any sort of multiplication sign, the number is always going to come in the front. So I wouldn't write R12 to mean R, yeah. If I want to say the rent times the 12 months, the most common way you're going to see it is that 12R. I want to come back in and define that variable. So we said rent. Can we make that more specific? What about the rent do you not know?
She pays each month.
So we don't know how much. Yeah, there we go. So R is going to be how much rent she pays each month. Try to make that as specific as possible. Your variable, we said last week. We said on Monday that we're using letters to represent numbers. So this should always be describing a number. So earlier when you said like R is for Rebecca, I was like, is it the human being? And you're like, no, wait, no. See how now it's describing a number. It's saying how much rent. You can use like how much or how many. If you're using those words, that means you're describing a number. If you just say Rebecca, then you're not describing a number, you're describing a person. This is definitely a skill that takes some practice. So guess what? We'll be doing more of this today. How are we feeling about this one? Okay? A little better than last. I keep wanting it to be last week. I feel like a lot has happened between Monday and now. Well, with that, we are going to be looking at more variables today. We are going to be doing something called combining like terms. I can simplify by combining like terms. We've seen this word simplify a lot at this point. When you're simplifying something, what does that mean?
Trying to get to the lowest term as possible.
So trying to get to the lowest term as possible. Simplify comes from that word simple. So in doing that, what you said, trying to make it the lowest terms as possible, we're trying to make it simpler. When we talked about simplifying fractions, we said instead of saying 50/100ths, it's much simpler to think of 1/2. Simplifying isn't just for fractions, though. It's for a lot of things in math. So we're going to be making math problems simpler today. Doesn't that sound great? With that, I'm going to start off with another of these questions similar to the one you just did on the Do Now. It says, Sarai is trying to save to buy a TV and puts money into her piggy bank to help her save. She put the same amount of money in her piggy bank 3 times this week. It says talk with a partner. There are 2 of you, so I'm going to give you the option if you want to move to the same table to talk through this. Or we can do what we've been doing where someone's going to write on the board and then you both talk through it. But the question you're going to be talking through in a moment is there are 2 different ways to write this expression. There are 2 ways to write the expression to represent how much money she saves this week. What are those 2 expressions? So, how do we want to do this? Does someone want to come up and do the writing on the board as we talk through this, or do you want to relocate and sit at the same table?
I can write it.
You can write? You're okay with that? All right. If you want to go up and grab one of those markers. I don't know if you saw. I was checking them all because I feel like these are the ones that are dead. But there's a black one right there. If they're dead, I should throw them out though. Wouldn't that make sense? Okay.
So M for money.
Ask her, not me.
M for money.
Yeah.
And piggy bank to help her savings. She put the same amount of money in her piggy bank 3 times this week. So times 3, M times 3, because we don't know how much she put in money.
Right.
in there.
Yeah.
So it's gonna be times 3 times because of times of this week.
Yep.
Probably. I'm trying to figure it out. I'm not good with this.
You're doing great. I would argue you're doing great. Remember, we said there's 2 ways to write this. So you've got one way. See if you can figure out the other one.
We do, 3 M.
3. Oh yeah. 3.
What's that one say?
3 times whatever the money is.
Yeah, 3 times whatever the money is. You have proven me wrong. There is more than 2 different ways. I would say those 2 are pretty similar, M times 3 and 3 times M. There is one that's completely different.
So like savings for S, right? And
You can use that same letter M.
So M. If I was saving money right now, and I'm trying to buy a TV, and like if I save that money times the 3 of the time of this week, so I just put S times 3 for that too, or no?
All you've done is change the letter we're using, but it's the same idea as M times 3. I'm gonna forget the variable for a second. Let's pretend I told you how much money she's saving.
Yeah.
Let's say she's saving $10 each time.
Yeah.
How much total money has she saved this week?
So 10 times.
$30. How are you getting $30?
Because she saved the same amount 3 times, so 3 times, 10 times 3 is 30.
What's another way you could do that math? Instead of 10 times 3,
We divide
division, what would you divide?
the amount of time to the amount of money.
You're changing the question. The question is, if I'm saying you're saving $10 each time, and you save it 3 times, one way you can figure out $30 is doing 10 times 3.
Yes.
What's another way you could figure it out?
Addition.
How would we use addition?
10 plus 10 plus 10.
So that amount of money saved, right? 10.
Oh, so M plus S.
So let's write something down. So what are you thinking?
So S plus M, because of the saving that she had. Like, what did you say? I'm trying to save to buy TV. Oh, so she had nothing. Then she had no saving. She barely started saving, right?
Francis is on the right track where we can use addition to figure it out. So one option is those multiplication problems you've got there. The other option, what would we want to add?
piggy bank. I don't know.
Savings.
Let's define the variable you've got right now. So you've got M. What does M represent?
The money for that. M is for money.
Remember we said earlier, be more specific. So we got M for money.
Is
M.
the money that she's trying to save, right?
She's trying to save in
to,
total.
to buy it. Yeah, to.
The amount of money she's saving total for the TV. The amount of money she's saving.
To get a TV. Amount of money.
It's the amount of money that she's putting into her piggy bank.
Yeah.
There you go. So it's that amount she put into her piggy bank each time. So let's write that somewhere. M is.
Oh, no, right here. What is it?
Why are you writing on the word problem?
Alright,
You can put it up by the
Right.
example. Yeah, we're there.
Alright, money.
Money she's saving in her piggy bank.
Money. Yeah, I'm so sleepy.
You got it. Money.
Saving.
She saved.
Mhm.
She's saving. In her piggy bank.
Yeah.
So earlier when you said M times 3, what that really is saying is that money she's saving in her piggy bank times the 3 times.
Yeah.
We've gotten to, that's one way we can write it. Francis said the other way we can write it is using addition. Don't change up your variable because we're still going to be using M. But what would we want to add?
As saving.
You're changing the variable. You already know it. We're
Yeah.
using M for the savings.
Yeah, but.
M plus M plus M.
There we go. Why is it M plus M plus M?
Wow.
Because it's the same amount no matter what.
Yeah.
No matter what
So,
it was.
M plus M plus M.
Mm-hmm. There we go. If we're using those words you said M is the money she's saving in her piggy bank. We've got, here's the money she's saving, plus she did it a second time, so here's the same amount of money she saved, plus the third time. So you've got the two, you gave me 3 ways, so you went above and beyond. You've got the M times 3 and 3M, which we said those are saying the same thing.
Yeah.
But you've also got M plus M plus M. Do those represent the same thing?
Yes, in a way.
Tell me what.
Because they all equal out the same amount.
Nice. So we could have figured, remember when I told you $10? You could get to that total $30 by using multiplication or using addition. It's different ways to get to the same answer. The same idea here. 3M and M plus M plus M are the same thing.
Yeah.
Carlos, thank you so much for writing. You guys did a great job with that.
I'm alright. I'm never gonna be a teacher though.
I mean, keep in mind, I've spent a lot of time with this math. I did not come out of the womb knowing variables. But you guys, you did great. This right here is what we wanted to get to. This idea that you can represent this with 3M, or you can represent it with the M plus M plus M. Those ideas are the same thing. Do you notice anything that these have in common?
Just 3 M's.
Yeah, both of them have 3 M's. This one literally says 3M, and this one says M plus M plus M. There's 3 M's. What we're doing today when we said we're talking about simplifying is it's going to be similar to the idea of I'm giving you this, and you're going to simplify it. You're going to make it easier on the eyes by changing it to this. I gave you a problem where she had only done it 3 times. What if I said she put that money in her piggy bank 20 times? We don't want to have to write M plus M plus M plus M plus M 20 times. That's why we've got this idea of simplifying things. There's some vocabulary that we're going to use that goes with this. So when I wrote this out, I used the letter S. Does it matter which letter we use for a variable? Does it matter that I wanted to use an S and you guys wanted to use an M? No. As long as I'm saying that S represents the money she's saving, we're good to go. So I said S plus S plus S equals 3S. the same thing as m plus n plus m equals 3m. There's two vocabulary words we've got with this. The first one is when you're looking at something like this, each part of that expression is called a term. So for that second expression you guys wrote, the m plus m, how many terms is that?
Three.
Three of them. You always separate those terms with a plus sign or a minus sign. Only plus or minus. That'll be how you see like the different parts, is there'll be a plus or a minus in between them. The other vocabulary word we've got for today is this number right here that's in front of a variable. This number in front we call the coefficient. Being able to look at a problem and identify the terms and identify the coefficient is going to be important for today when we go to combine stuff. You've got to be able to identify both of those things. So we're going to start off, it's not even any math yet. We're just going to start off identifying those two things. So for these first four questions, or these first four problems, the question is how many terms are in each of these expressions? So for example, this first one, it's all numbers, 5 plus 12 minus 1/2. How many terms is that? Three. We've got 1, 2, 3 terms. I'm going to have you try the other 3 and then we'll talk through them. You see where we're at? Yep. So you're just going to tell me how many terms there are in those other 3. Okay. This question is different, so you're just worrying about 1 through 4 right there. Uh-huh. Is it 2? They're all called terms. So here it would be 2 terms. All right. Number 2. Francis, how many terms?
3.
Why is it 3?
Because it's x plus y minus z.
So the 3 terms are?
X, y, and z.
Yep. Perfect. Again, notice we're separating them with a plus or a minus sign. Number 3, 2b plus 3b. What are those 2 terms here? The 2b and then the 3b. Why is that not 4 terms? I see a 2, I see a b, I see a 3, I see a b.
Not separated in the middle.
Yep, you got it. They're together. When it's together, it's one single term. If it's separated with a plus or a minus sign, then we get more terms. The last one, xy?
1.
Nice. 1 term, same idea. It's not separated by anything, which means it's all together. It's one single term. How are we feeling about identifying terms? I think the key idea is what you said. Look to see if they're separated. If they're not, if they're written together, it's all one big term. The other word we learned is coefficient. What was a coefficient again? I like how you're flipping back. Find that word. What's a coefficient?
The number in front of a variable.
Yep, the number in front of a variable. So for number 1, 10a, the coefficient is 10. The number in front is 10, so the coefficient is 10. Go ahead, try 2, 3, and 4. I did give you the more fun ones. Yeah. Yep, you got it. So use what you're saying in 3 to help you with number 4. That's one of them.
That's getting me.
It's similar to number 4. Or sorry, number 4 is similar to number 4. Number 4 is similar to number 3.
Just one.
Kinda. All right, let's talk through them. Number 2, what is the coefficient?
12.2.
What's the number in front of B?
2.
Nope.
12.
You keep leaving something off.
Negative 12.2.
Yeah. Why don't you like that negative sign? Negative 12.2. If it's negative, that's part of the coefficient. It's part of the number. Now 3, Carlos, I saw you got it. What number did you say?
1.
Why is the coefficient 1? Is it just something you've learned in the past and you just remember it? Which is great. Let's talk through why it's 1 though. Remember earlier when we had the 3m equals m plus m plus m, and I asked you what they had in common? Do you remember what you said they have in common? They both have 3m's, right? We said over here I see 3m's, so we're saying there's 3m's. How many x's do you see? 1. So that's why we say that coefficient there is 1. I don't need a number to tell you how many there are because there's only 1. We see the 1x. What that means is if you ever have a variable that does not have a number in front, the coefficient is, if you have a variable where you don't see the number in front, the coefficient is 1. So use what we just learned there to help us with number 4. Number 4, what would that coefficient be? What do you see in front of the variables? There you go. There's that negative sign. So it's just like this one, except now the coefficient is negative 1. How are we feeling about identifying coefficients? Not bad. Okay. Okay. All right. It is time for the math part now. If you are able to identify coefficients in the terms, then it helps you do what we're focusing on today, which is combining like terms. In expressions like these, you can add or subtract terms. Remember, the terms are just the different parts. So you can add or subtract them if they have the same variable. Remind me, what's a variable?
A letter.
The letter. So if they have the same letter, the same variable, and they have the same exponent. It's been a second since we've seen that word. What's an exponent? Nope, those are parentheses.
Square.
Yeah, squared, cubed, it's that little tiny number. So, for example, something like a cubed and 3a cubed, do they have the same variable?
Yeah.
Yep, they've got the same letter. Do they have the same exponent?
Yes.
Yep, so that means we would be able to add or subtract those together. Something like this?
No.
Why not?
Well, you can.
Well, they have the same variable, not the same exponent.
Correct. They don't have the same exponent. They don't have both of these in common. It means we can't add or subtract them together. They would have to stay separate. What we're doing right here is looking for like terms. Like terms are what you call these things that have the same variable and the same exponent. So we said today we are going to combine like terms. Combine is just talking about like adding or subtracting them. We are looking for like terms. If you have like terms, it means you can combine the like terms, which just means you can add or subtract them together. So for example, number 1 says 5x minus 2x. Before we do anything, we want to check for this. So here, how many terms do we see? How many terms do we see? 2. There's two parts to the problem. There's a 5x and that 2x there. Are those two terms like terms?
Well, different number.
They have different
They have
numbers,
that
but what do they have?
same X, though.
They've got the same variable because you said they have the same x. What about the exponent?
There's none.
There's nothing. So they're the same. After the number, they look the same. That means we can combine them.
Yeah.
I already heard you do it.
Yeah, 3x.
Yeah.
How did you get 3x?
About 5.2.
Yeah. So what you're doing is you're just doing the math with those coefficients, those numbers in front, and then you're just copying over the variable that comes after. Now we can make these even more fun by adding in more terms. So in number 2, how many terms did I give you here?
But the 2, wait.
3.
Yeah.
3 terms. What are the 3 terms?
2
squared.
Wait, I mean 2.
2a squared
And 5a
2
squared.
and 5a squared
and 2.
and the 2. So there's 3 total terms. Can I combine everything together?
No.
No.
Why not?
The only ones you can do is 2a squared and 5a squared.
Why can't I combine this one?
Because it doesn't have the same variable or exponent.
Perfect. Doesn't have the same variable, that a, doesn't have the squared. So I heard 2a squared and the 5a squared. When it comes to combining, you want to be careful with the signs. Up here, because of that minus sign, you knew to subtract them. I've got 2a squared. What do I want to do with that 5?
Can you add them or no?
Subtract it,
Why subtract?
because, you're going to be adding the 2a squared with the 2 with the subtract 5 is the 7.
That's perfect. I don't know if you could hear. She said we're going to be adding the 2. That plus goes with the 2. Look at what's in front of that 5a squared. It's the minus sign. So what a lot of people do is what I'm doing right here by putting like boxes around stuff. And if you choose to do that, make sure you include the sign in that box. So I'm doing that to help me see. You had told me earlier we want to do 2a squared minus 5a squared. What is 2a squared minus 5a squared?
3a squared.
Negative
3 or negative 3? Which one? Why is it negative?
You keep the guy on bigger number.
Perfect. Keep that sign of the larger number. So we get negative 3
3. A squared.
a squared.
That's it.
I love how you're already saying plus 2. I'm going to ask a question real quick. Did we do anything to the exponent?
It's still the same,
It's still the same. So again, notice when you're combining stuff, you're just doing math with the coefficients, those numbers in front. Everything else stays the same. It's still a squared. And you said plus 2. Why am I writing down plus 2?
right? I can forget it. Plus 2.
Why can't we forget it?
I remember, I had it like a D, that's why I left it.
You got it.
To make it more sense, you know?
Yeah, it's still in the problem.
With the problem, yeah.
So we got to keep it in our answer. Now I've got negative 3a squared plus 2. Can we add those together?
No, you can't have it.
Why not?
Because 2 doesn't get the variable.
Yeah, it's the same thing you told me earlier, right? That 2 still doesn't have the same variable and exponent. They're still not like terms. So this is as simple as it can get. That would be our simplified answer. Got one last one, number 3. Tell me what you're thinking for number 3.
We can add 1p plus 2p.
Okay, so we can add 1p plus 2p. I only see p. Why are you saying 1p?
Well, you can't put 1 in front of it.
Yeah. It goes back to what we learned earlier. We said earlier, if you've got a variable, you don't see a number in front. That number is 1. So that helps us out that you're already thinking of it as 1p. So you said we could add 1p
2
plus 2p.
And you can put plus 1, 1 plus 5.
Yeah. And we can also add the numbers, the 1 plus the 5. I feel like that green's not going to show up on camera. So other table, help me out with that math. The 1p plus 2p,
3p squared.
3p squared. How are we getting 3p squared?
2p.
Well, tell me first, where did the 3 come from?
The 1
1.
plus 2.
Okay. What about p squared?
The p plus the 2. P plus the 2.
Remember what we said up here. Remember when I asked you about that exponent? I think you were the one who told me. Did we change the exponent? No. You are only doing the math with the coefficients, with those numbers in front. Everything else stays the same. So there's something I want to change about this. What do I want to change?
Square.
What about the squared?
Square.
Just erase it. It's 3p. We're doing the math with the coefficients, the 1 plus 2. Everything else stays the same. So we got 3p. Francis, finish it up for us.
Plus 1,
Plus 1,
plus 5.
plus 5. Alrighty. So we get 3p plus 1 plus 5. Anything else we can do?
So 1 plus 5 will be equal to 6.
Yeah.
3 plus 6.
So we can finish up by combining these two. We got 3p plus, what am I doing? 3p plus the 6. That 6 is coming from the 1 plus 5. Now you guys did 3p plus 6. And I wrote down the 3p because that's what you told me to combine first. You said I see 1p plus 2p's. That gives us 3p's. What if someone else, let's say my afternoon class, decides to write 6 plus 3p? What do you think about their answer?
9p.
9p? So you think they should go further and say 9p?
They're gonna be like, oh, flip it, I guess, to make it more sense.
Let's pause first with the 9p. Does this equal 9p?
It does if you get really going more with it because it doesn't have the P behind it.
Okay. So, and you're saying no? Why does this not equal 9p?
6 don't have the P.
Yeah, it goes back up to this part here. In order for us to add them together, they have to have the same variable. Heard you say it doesn't have the P, so there's no, we can't go further with it. So this is their final answer. This is our final answer. Are they wrong? It looks different than ours.
It's the same thing, it's just flipped.
Yeah, I heard you using that word flipped too. Think about what you already.
It was gonna look nicer if you just put 3P. I'm just
So
saying.
what I'm hearing is you like your answer more.
Yeah, it just like makes it like more clean. That's what I think.
They're I'm not going to say what I was about to say, but you agree that these are saying the same thing. You think yours looks nicer.
Yeah.
Maybe they think theirs looks nicer. But they, at the end of the day, they're the same thing. This goes back to what you guys already know about numbers. Forget the letters for a second. You already know that 3 plus 6 and 6 plus 3 are the same thing. Maybe you have an opinion of which one looks nicer, but they're the same thing. With addition, you can change the order of stuff. Same thing is true with variables. If I was grading homework, this would get marked right, this would get marked right. So be on the lookout, especially with like a multiple choice question on the homework. If you get this might not be the one I've got written as an option. It might say this instead. They're the same idea. Now, if this, we already know it's 3p plus 6. I'm going to change something a little bit. Is this and this the same thing?
No.
You were so quick to say no. Tell me why.
Because you can't subtract 3 from 6, but you can subtract, you can't take 3 from 6, but you can take 6 from 3.
So you're going back to numbers again. You're saying, I know 6 minus 3 and 3 minus 6 aren't the same thing.
Because you can't subtract the higher
Mhm.
number from a smaller number.
There's another way we can reason out that these aren't the same. That's one reason. What's another reason we could say why these aren't the same thing?
Did you say it ain't the same thing?
They're not the same thing.
Oh, okay.
Yeah.
I'm telling you, it looks clean.
It has. Here, what's the sign of the 3?
Yeah, it's like-
The sign. When I say sign, what does that mean?
Positive.
Yeah, like positive or negative. So here the 3 is positive. What's the sign of the 3 here?
Oh, it's telling it negative 3P.
It's negative.
Yeah.
So when it comes to subtraction, you went back to this. With addition, we can change the order, and it says the same thing. With subtraction, it does not say the same thing. And it has to do with the signs here. They're both positive. It doesn't matter the way you add them. But here, that 6 is negative. Here, the 6 is positive. Here, the 3 is positive. Here, the 3 is negative. So those would not be the same. So you want to be on the lookout for signs.
So, like, if the P, if it was negative, what happens if the 3P already has negative? Like, let's say.
Like this?
like for example, like a question, like let's put -1, right? Like at the front of it, 6.
At the front of this.
Like
Tell me exactly what you want me to write. I'll write it down.
So, you know how there's questions, right? Let's say like for example like that one, -4x,
Okay.
and change it to -8. What do you do with that instead? Like, can you do like 8?
Like that. Carlos wants us to do a bonus question. I love it. How can I say no? He's asking, what about something like this? What could we do there?
It's not, the number one is positive 4, no.
Yeah, he's giving us a bonus question. He's saying, what about something like this? How could we do a problem like this?
Negative plus negative, positive. Positive.
So you're saying, what I'm hearing you say is we can combine these.
You can?
Can we?
Yeah.
We can. So it just goes back to -4. I heard you say a negative and another negative. What do we do with those?
Plus.
We add them. So that would give us,
Negative,
why negative?
because the sign is the same.
Yep. When they're both negative, you add them, but you're keeping that sign. You can always think of it as keeping the sign with a larger number. You could also go back to all the different problems we've done with like money. This is like owing $4. This is owing $8. So now you owe a total of $12. But it's similar to this first one we did here. You just have some negative numbers to worry about. I love your questions though. Thank you for the bonus math problem. Are you ready to try these 3?
So what's the answer today?
To which one?
So number 3.
This one?
No,
This one?
Yeah.
We originally had it, but I changed it around. What was the original answer? For,
P plus 6.
yep. We said you could have 3p plus 6. And then we also said you could have also written,
6 plus 3p.
yes, the less pretty one. All right. I'm going to give you, I'm thinking like 2 minutes to try 1 through 3 over here. We'll have one last example we look at, and then we will be done. Those first 2 are good. This one here,
Can
you got the right idea.
Can I do this? And after that, maybe plus -1, something like that?
Negative. You can do -1. Don't forget your z though.
Oh, yeah.
So the mistake you're making on number 6 has to do with adding those negative numbers. You're combining all the right things. What we just talked about with that bonus problem you asked me might help. If you look back to the -4x minus 8x. Those first 2 look good. Mm-hmm. Mm-hmm. Take another like 10 seconds to finish up. Tell me how you got 0.
Because -17. The 3 would just be.
Okay. There's one thing we gotta change there. Let me see what you finally came up with. Okay. It looks like we've got number 1 and number 2 perfect. Number 1, let me write them down real quick. Number 1 was,
12x
number 2 was,
13y squared
plus 9 and 6y cubed.
Nice. Yep, cubed. Number 3, what I see you all doing is you're all combining the right stuff. It looks like we're not liking the negative numbers. So let's start first. For number 3, what's one thing we can combine?
4 plus 10.
Okay. Well, you gave me the 2 options. So Carlos said 4 plus 10. That gives us 14. I saw 14 on everyone's pages. Now you said we can also combine.
Minus 7z
Uh-huh.
minus z.
Perfect. So when I combine the negative 7z and the minus z, I only see a number here. What's the coefficient here? 1. So the math we need to be thinking of is negative 7.
Plus 1.
Plus
That'd be,
Oh,
negative
wait, I don't see plus 1. I see negative 7
Plus the
negative 1.
V1.
minus 1.
Or minus 1.
Remember, if you're looking at this plus sign, that's on the floor. The floor. That's that is on the 4. We want to be thinking of negative 7 minus 1. What is negative 7 minus 1?
6.
Ugh.
8. Negative 8.
Negative 8. This is just like that problem we looked at. Remember that bonus problem? The negative, what was it? It was negative 4x minus 8x. And we said negative 4 minus 8 earlier we said is negative 12. If they're both negative, you add and keep that negative. Same idea here. Negative 7 minus 1 is negative 8. So what that means here is negative 7z minus 1z is,
Negative 8.
yep, negative 8z. Is there anything else we can do for number 3?
Nope.
Nope. So we've got
Like that, I make it 8z plus 14.
negative 8z plus 14. What do we think?
Yeah. Plain 2.
I love your appreciation for clean looking answers. My question is, are these mathematically the same?
Well, there's 2 additions, right? The math, right? Or the
When you say 2 additions, tell me where you're seeing them.
plus 4 and plus 10. Does it, like,
Uh-huh.
that's how you get the plus. And like,
So that's how you get that
8
positive
plus
14.
Yeah.
So the positive 4 and the positive 10 gives you that positive 14. Do we have positive 14 here?
Yeah.
Do we have positive 14 here?
Yes.
Yep.
And after that, there's the negative.
Mhm. So the negative 8z. Do we have negative 8z here?
Yes.
Do we have negative 8z here?
Yes.
Yep. So are they mathematically the same?
Yes.
Yes. And clean looking. This just goes back to what we had been saying for this problem. You've got it in a different order, but it's saying the same thing. Both of them are saying positive 14 and negative 8z. So it's good. The last question I've got, it goes back to these word problems, representing them with variables. This one here says, Olushola saved that's not a 7, that's an S. Saved S dollars this week. He went to Walmart and spent the money he saved this week. Write an expression that represents this.
No,
He saved S dollars, and then he went to Walmart and spent that money he saved. I'm going to give you 30 seconds, write down an expression, and then I want to hear what we've got. He saved S dollars this week, and then went to Walmart and spent the money he saved. Yep, yep. I love how you're defining variables. It already told us the variable, so we're going to use what they told us. He saved S dollars. Uh-huh. Because they already gave us the variable there, you don't need to worry about that.
Oh, no, it's just another one.
All right. So for our expression, I think the first thing I saw that all of you had, what operation were you using? Minus, subtraction. Why do we want to use subtraction?
Because she's spending money.
Yeah. We're spending money. We're taking away what the money he spent. So all of your problems have got subtraction signs in them. What is he starting with?
With the S or dollars that we.
Yeah. It tells us already that we're going to use S for that money he saved, so we don't need to worry about defining a variable. This is an example of a problem where they give you a variable. If they give you the variable, we've got to use the one they're giving us. If they hadn't done this, you could pick whatever letter you want. But because they gave us S, we're going to start with S. So we've got S represents the money he saved. He's spending money. What did he spend?
Spend the money he saved.
He spent the money he saved. So we've got S. S is the money he saved. And he spent
I put S spend.
S or M. Which one do we want to use?
I put S for spend because how much you spend the money.
It's going to come down to if we put different letters, that means they're different amounts. If we put the same letter, the same amount. Are these different amounts?
No.
No, why not?
He spent the money he saved.
Yeah, it says he spent the money he saved. He spent the same thing he saved. If it's the same, we got to use the same letter. So we're going to say S minus S. S minus S. The second part says if he spent the money he saved, how much money does he have left?
Zero.
Okay, we got that one. He's got $0. Remember, this is the problem we wrote. This is the expression. What this means is S minus S equals 0. This is important because this means when you're given an expression and we're trying to simplify, like we were doing a moment ago, if you've got the same thing here, when you're subtracting, it's going to leave you with 0. What about something like 2S minus 2S?
Still gonna have zero. 2 minus 2 is 0.
Ooh, yeah, so you're going back. I didn't mean to cut you off. You're
2 minus 2 is 0, so it'd be 0S.
nice. So is 0, what is 0S equal to?
0.
0. It's kind of similar to what we were saying earlier. Remember when I keep going back to this one. I should just keep it on the board. Remember earlier when you told me they both have 3 S's in common? And then we said, well, here I only see 1 S. So S is the same thing as 1 S. 0 S is the same thing of having 0 S's, which is no S's. This idea here, this idea if you're subtracting the same thing, it gives you 0, is the last piece of information you need for these. So there are 3 on the bottom you're going to try. Those are your 3 problems. And we'll do like 2 minutes. And then we'll see how you do. And people at home, this is where I will leave you. So goodbye.